This is Advanced Math 12.3 homework questions. That's Advanced Math Unit 12, Lesson 3 homework questions. And these are the problems here that I'm going to cover, starting off with number 1, log base 10 of 0.12345 zeros and then a 1. And it's asking us to evaluate. When you're asked to evaluate, what I told you in notes, if you remember, I said it's not going to have an equals x. You're going to put the equal x in there. The one I'm doing is very similar to number 3 in the notes. So I'm going to set it equal to x. And I'm going to do the wraparound. 10 to the x power, that's how logarithms work. 10 to the x power equals. And I'm going to change this to a fraction. 1 over tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. Or an easy way is just count everything including the 1. 1, 2, 3, 4, 5, 6. There's going to be 6 zeros. All right. 10 to the x equals 10 to the 6th power is a million, so 10 to the negative 6th power would give me this fraction here, 1 over a million. And because the bases are the same, there's 1 on each side, I drop them, and x equals negative 6. Okay. Number 3. Log base 2 of 2 squared plus 2 squared. And again, on all of these, we are evaluating. So even though it doesn't have an equal x, I'm going to put it there. And we're going to ask ourselves, 2 raised to what power is 2 squared plus 2 squared? Okay. Now, I'm going to use u substitution. We've done this a few times by now. Let u equal 2 raised to the 2nd power. So I have 2 to the x equals u plus u. 2 to the x equals 2u, 2 to the x equals 2, and then I'm going to plug the u back in, times 2 squared. And because the bases are the same, I can add the exponents, and I'm going to do that because I want to condense it down to one base. I can't drop the bases if there's multiple bases on either side. So 2 to the x equals 2 to the 3rd power. 1 plus 2 is 3. Now they're the same, there's 1 on each side, I can drop them, and x equals 3. Alrighty, number 4, log base 7 of the cube root of 49. And I am going to set it equal to x. It doesn't have that, but if I'm evaluating, I want to put it equal to x so I can do the wraparound, because what they're asking you here is 7 raised to what power is the cube root of 49. Okay, 7 to the x, I'm going to get 49 to the same base as 7, and 7 squared is 49. And then I'm going to change this to exponential form, 7 to the 3/2 or 7 to the 2/3. It is 7 to the 2/3, same base, 1 on each side, you can drop them, x equals 2/3. All right, number 5, nope, I don't know why I put a 5, number 12, log of 1 over 1,000 raised to the 4th. Okay. There's 2 things are going to happen. I'm going to put equal to x even though that was not there, and I'm going to remind myself that's a base 10, because if there's no base 10, if there's no base, it's automatically a base 10. And then I'm going to do the wraparound. 10 raised to what power equals 1 over 1,000 raised to the 4th power. All right. I'm going to change this to a base of 10. 1 over 10 to the 3rd. And I want to, I'm actually going to rewrite that. If 10 to the 3rd is 1,000, then 10 to the negative 3rd is 1 over 1,000 raised to the 4th. Multiply the powers, because it's a power to a power. So you get 10 to the negative 12th, one base on each side. They are the same. Drop them. X equals negative 12. All right. Number 15. 15 is a different section. It is write as one log and simplify if possible. This is where you're going to be using your log laws to condense. So they're going to write it like this in expanded form, and you're going to condense it down to a single log. So you're going to go from a double or a triple or quadruple log and condense it down to a single log every time. Okay. Number 15. Log of x to the fourth, not squared, of x to the fourth minus 4 minus the log of x squared plus 2. Okay, and I want to bring this down, or condense it to a single log. Now I can only do that if they have the same base. They both have a base 10. And if you remember from the notes, a subtraction becomes a fraction. Subtraction becomes a fraction. Kind of rhymes. Okay, log base 10, I'm not going to write the base 10, of a single fraction, x squared minus 4 at the top, x squared plus 2 at the bottom. And the next thing you ask yourself, can I simplify? Anytime you have a fraction, you're always going to try to simplify. And I can factor x, I keep writing that as squared and I apologize. You can factor x to the fourth minus 4, x squared plus 2, and x squared minus 2 because it's difference of two squares, over x squared plus 2. Reduce, x squared plus 2 reduces. And you're left with log of, everything's gone except for the x squared minus 2. All right. Okay, I'm moving on. Next one is 16. All right, 16 reads log of x over y minus 2 log of x cubed minus log of y to the negative fourth. All right, I'm going to do a little bit of changing. First one I'm going to do is take this and bring it up to the power. So log of x over y minus log of x cubed raised to the second, because that comes up as a power. I'm just going to fix that just a smidge. It comes up as a power, so it's this whole thing squared. And then I'm going to change this to a fraction, minus log of 1 over y to the fourth. Okay, I'm going to multiply my powers. Log of x over y minus log of x to the sixth minus log of 1 over y to the fourth. Okay, I'm just going to go from left to right. I'm going to combine those two first. Now, because it is subtraction, I am going to make it a fraction. X over y minus, over x to the sixth. It's going to look a bit wonky. I am going to fix it. X over y all over x to the sixth over 1. Now I wrote it that way so I can multiply by the reciprocal. So top fraction minus x to the sixth, that's the top and that's the bottom. And I'm just going to leave this as is. And then I'm going to multiply by the reciprocal. Log of x over y times 1 over x to the sixth. The second piece is just going to stay. Okay, and then I'm going to move my work over here. I'm going to reduce here. X is gone, x to the sixth becomes x to the fifth, leaving log of 1 over x to the fifth y minus log of 1 over y to the fourth. Okay, do you see how that worked? This reduced, so log of 1 over x to the fifth y, and then this is just staying as it is. And let me make sure I have everything done correctly. I did mess up in one place. It's not going to change any of our work at all. It's just, I just didn't make that a plus. And I'm sure some of you are like, what the heck is she doing? It's just a plus, a plus, a plus, which again doesn't change any of my work, but it's going to change my next step if I hadn't fixed it already. Okay, so addition is multiplication. That was in your notes. It's also on your worksheet. So I'm going to multiply these two fractions. Log of 1 over x to the 5th y times 1 over y to the 4th. Add those exponents because they're like bases. Log of 1 over x to the 5th y to the 5th. And you don't need parentheses. If you don't put the parentheses, that's fine. All right, the next one I am doing is number 18. 3 log of 5 plus 2 log of 8 minus 2 log of 4 minus 4 log of 2 minus 1/2 log of 25. Okay, first thing I'm going to do is anywhere there is a coefficient, which is on all of them, I'm going to bring it up as a power. So I'm going to have log of 5 cubed plus log of 8 squared minus log of 4 squared. So I leave the negative there and only the 2 moves up. Same thing here, minus stays log of 2 to the 4th minus 1/2, and nope, that's moving up as well, minus log of 25 to the 1/2. Now, if you did want to move up a -2 instead of a +2, you could, then that minus would become a plus. You don't have to do it that way. Okay, so this is log of 125 plus log of 64 minus log of 16 minus log of 16 minus log of 25 to the 1/2 power is a square root of 25, which is 5. Okay, I'm just going to go from left to right. Now, technically, if you wanted to, you could combine those two like terms and call it -2 log of 16 and put the 2 up as a power. You could do that. I'm not going to, but it's perfectly fine if you do. All right, so I'm going to combine these two first. It's addition, so I'm going to multiply. Log of 125 times 64. Yes, 125 times 64 equals 8,000. So log of 8,000 minus log of 16 minus log of 16 minus log of 5. And then I'm going to combine these two again. I'm just going from left to right, and this is going to become a fraction. Log of 8,000 over 16 minus log of 16 minus log of 5. Now here it's up to you on how you want to do it. The answer key has it as a fraction, so if you want to keep it looking that way, because if you divide 8,000 by 16, you are going to get, oh, nope, this one, you don't have to worry about it yet. This one we can divide. Okay, so we get log of 500. It's in the next step that we'll worry about the decimals. Minus log of 16 minus log of 5. Okay, here it is here. Log of 500 divided by 16 minus log of 5. Okay, 500 divided by 16, you get a decimal. If you want to write it as decimals, there's nothing wrong with that. You can, and then divide it by 5, and you get log of 6.25, which is perfectly fine. If you want to keep it the way it is on the answer key, I'll show you how to do that now. On a multiple choice test, on an open response, either way, decimal or fraction, I would not care. On a multiple choice question, if you wrote it as a decimal and their answer is a fraction, just compare that your decimal and their fractions are the same. Okay, so how do we do this? I am going to reduce 500 over 16. I'll do that over here. I'm going to divide top and bottom by 4. 16 becomes 4, 500 becomes 125. That's dividing top and bottom by 4. So I get log of 125 over 4 minus log of 5. Okay. Moving on, I'm going to write this as a fraction. Log of 125 over 4 over 5 over 1. And I'm going to multiply by the reciprocal. Log of 125 over 4 times 1 over 5 and cross reduce. 5 goes into itself once, goes into 125 25 times. So I'm left with log of 25 over 4, which is what the worksheet has as their answer. Again, if you just change to a decimal right here to a decimal and then another decimal, you would end up with log of 6.25. And I would accept either one on an open response question to a test. All right. Okay, that is it for 18. I am moving on. Now, this next section has the ones that kids typically struggle with. So I'm going to write down the given information. Log of 4 equals m, and log of 6 equals n. And they're going to give you a bunch of log of 24, log of root 6, excuse me, log of 40, a bunch of them to rewrite using m and or n. Okay. Now, what do? First off, remember there's always a should know. What is your should know when you're working with letters like this? Your should know is always going to be whatever base you're using in this problem. This one happens to be a base 10. You don't see them, so you know they're base 10. So log base 10 of 10 is what I'm going to write. Say these were a base 4, or no, let's say base 5. Let's say they were both a base 5, then over here my should know would be log base 5 of 5. If both of these bases were 7, then my should know would be log base 7 of 7. Either way, it's always going to equal 1, because 10 to the first power is 10. So not only am I able to use 4 and 6, I'm also going to be able to use 10. When I go to rewrite, I'm going to use 4 and or 6 and or 10. All right, and when I rewrite them, I can rewrite them using multiplication, division, or exponents. All right, number 19. Log of 24. We'll start off with an easy one. Log of, is there any way to get 24 using 4 and or 6 and or 10 using multiplication, division, or exponents? Yes, I can do 4 times 6. Now, be careful. The biggest mistake kids make on the test is this is a mistake, so don't write it. I'm just explaining it. They'll say, oh, 4 times 6, so it must be m times n. And that is wrong. Please, please, please. You use multiplication and division and powers to rewrite it, but your final answer should have addition signs or subtraction signs, or coefficients like 2x or 2n or 2m or 1/2 m, but no multiplication or division or exponents. So these should not be in your final answer. Okay, so what we do, this is the correct way. We break it up. Log base 4 plus log of 4 plus log of 6, because that is our log law that we had in notes. When it is multiplication, it becomes addition. So now we're expanding instead of condensing. All right, log of 4 is m, plus log of 6 is n, so m plus n is the answer. All right, 25. Log of root 6. Okay, is there any way to get this without the radical using 4 and or 6 and or 10 using multiplication, division, or powers, exponents? Log of 6 to the 1/2, because 6 to the 1/2 is equivalent to the square root of 6. Why do I want to use a power? Because one of my log laws is bringing this to the front. Okay, so here's the mistake kids make. They say, oh, Log of 6 is n, so this must be n to the 1/2, and that is wrong. Again, your final answer should not have powers or multiplication or division. So what I do is I bring the 1/2 to the front. 1/2 log of 6 equals 1/2 log of 6 is n 1/2 n. So you can have coefficients, but not powers like that. N to the 1/2 is not the right answer. Okay, next one is 29 log of 40. Now here's where kids start to struggle. Remember, I can use multiplication, division, and powers, exponents, using 4 and or 6 and or 10. Now I'm hoping you can see we're going to use 4 and 10 because log of 40 is log of 4 times 10. Now if you forget the should know, then you're never going to get the 10 because there's no way to get 10 using these two numbers. Kids will say, oh, 4 plus 6, but I can't use addition. I can only use multiplication, division, and powers. Why? Because that's what my log laws are, multiplication, division, and exponents. Okay, so I'm going to write it as log, break it up, don't forget that, always break it up. Log of 4 plus log of 10. If you do not use your log laws, you've done something wrong. Log of 4 is m plus log of 10 is the same as log base 10 of 10 is 1, m plus 1. Okay, 31 is very similar. Actually, yeah, 31 is very similar. It is log of 60. And again, 4 and or 6 and or 10. I'm going to use 6 and 10. Log of 6 times 10. Now if I plug in my m in or 1 at this time, I've made a mistake because I've not yet used my log laws. Pull it apart. Log of 6 plus log of 10. And log of 6 is n plus log of 10 is 1, n plus 1. All right, the next one I'm going to do is 33. Did I skip one? 19, 25. I did. I skipped 28. Sorry, I'm going to do 28 now. Log of 1 over 36. Okay, I want to get it to a base of 4, 6, or 10 using 4, 6, or 10. So 4 times 6 or 6 to a power, 4 to a power. I'm going to use a base of 6 with the power. I'm going to use it with the power. Log of 6 raised to the what power? Now, negative second power. Do you guys see that? 6 squared is 36, so 6 to the negative second would be 1 over 36. Those two are equivalent. Now, again, you do not plug in the n. Kids will say, oh, n to the negative 2. That is wrong. Your final answer should not have powers or multiplication or division. You have to use your log laws. So I'm going to bring this to the front. Negative 2 times log of 6, which is negative 2n. So it can have coefficients, but not powers. Okay, negative 2n. All right, and lastly, I'm going to do number 33. Log of 20 over 3. All righty. Now this one's a little more complicated because how do I get a 20 out of 4 and 6 and 10 and or? And how do I get a 3? And I can't use 2 at all. So here is what I suggest. Get the 20 over 3 and find equivalent fractions, like reduce or multiply or do whatever you can do. It doesn't reduce, so I'm going to multiply top and bottom by 2. If that doesn't work, I'd multiply top and bottom by 3 or 4 or 5. I'm going to start with 2. 20 times 2 is 40. 3 times 2 is 6. These two are equivalent fractions. You'll learn that in elementary school, equivalent fractions, because if I reduce 40 over 6, I'd end up with 20 over 3. Okay, now, is there any way to use any combination of these numbers to get 40 over 6? There is. So I'm going to put my arrow over here. Log of 40 over 6 equals log of 40 is 4 times 10 over 6 is just 6. 6 is one of the numbers I can use. So are these two exactly the same? 4 times 10 is 40 divided by 6. 40 over 6, does it reduce to 20 over 3? Yes. So I'm changing the way it looks but not changing the value. Okay, so there's multiple log laws I'm going to use here. I'm going to do it this way first. Log of 4 times 10 minus log of 6, because I cannot plug letters in yet because I have to rip things apart. I have to use my log laws. So top minus bottom, and then the top piece is going to become log of 4 plus log of 10 minus log of 6, and log of 4 is m plus log of 10 is 1 minus log of 6 is n. The worksheet, the answer key writes it like this, which is exactly the same thing. You don't have to write them both ways. You decide which way you like and you keep it. All right, that is it for this section of homework questions.